Okay, so this one is different. So no more machine learning. This one is about containers, and so it's a short overview of container services. Okay, so it's just for awareness. I really won't go into a lot of technical details. So, but I guess it kind of ties into SageMaker since it's container based as well. So we have 4 services for containers, right? ECS, EKS, Fargate to actually run containers, deploy containers, and ECR, which I already mentioned, which is the repository where we push containers. So who's already using containers? Okay, quite a few people. So the reasons why we like containers is they help you package applications. It makes it easy to separate your app from any dependency on the host. You can move them around from environment to environment. You can even exchange them with other people. It's just a cool way to package and distribute apps. And they help you build what is called immutable infrastructure, where you never modify production infrastructure. You deploy, and if you need to change something, you tear that thing down and you deploy something new. But you never change configurations. You just deploy newer versions. So you always know in what state your infrastructure is. Okay, immutable infrastructure was a significant progress in managing platforms. So we've been building containers for a while now, and the first service that we built is called Amazon ECS, dating back 2016. Could be reInvent 2015, late 2015. Yeah, late 2015. So ECS was our first service, and we released it with a companion service called ECR, so the Docker registry. So ECS it simply lets you create Docker clusters on AWS. It's based on EC2, okay? So you create Docker clusters from EC2 instances, and as it's based on EC2, it will feel very familiar, okay? So if you know about EC2, if you know, again, VPC, load balancing, security groups, auto-scaling, CloudWatch, all that stuff, ECS will use that as well, okay? So we provide a backend that will schedule your Docker containers, that will make sure you have enough resources on the cluster, etc., etc. So it's just a simpler way to build and deploy clusters. Again, ECR is needed because, of course, if you need your containers to be close to your clusters, and in order to deploy quickly. So, ECS has been successful. It's grown a lot, and now we have, if you can believe that number, we have millions of EC2 instances that are actually used for containers, right? Used by ECS. That's the scale. People always are curious about the scale of AWS. Well, there you go. So ECS is millions of instances. Okay, that's a crazy number. So we have tons of customers. Containers have grown a lot in popularity. If you're curious about those, again, I'm not going to spend any time on that. You can go to our website and look at all those stories. But everyone is doing microservices these days. Everybody's using Docker even to solve deployment problems. So if you ask me who's using it, it's literally everybody. From startups to big accounts, and literally everyone is using that stuff. Okay. So the initial problem that we wanted to solve is make it easy to create clusters, right? Because again, people don't want to manage clusters. They want to run applications. Okay, so having to set up your own Docker cluster and manage it and fix it, it's exactly the same discussion as SageMaker. You don't want to focus on infrastructure, right? Infrastructure is a tool that you need to get stuff done. So if that takes as little time as possible, then fine. And that's what ECS was built for. But then, okay, as containers became more and more important to customers, we worked on making this as efficient as possible. So actually, we have an SLA now for ECS. Okay, so Our SLA is 99.99. So there you go. So if you deploy on ECS, that's the promise that we're making, that our backend, our scheduling features will run at 99.99 availability. Okay. That means, quoting from memory, I think that means a few minutes of downtime per year. Yeah, a couple of minutes. But usually we exceed it. And then over time we added more features, and an important one was service discovery. And for the microservices crowd, this is really important. It's fine to break your applications into 20 pieces and deploy them as independent pieces on a Docker cluster, but they need to talk to each other, right? So for each service needs to be able to figure out what's the IP address and what the port number of the other piece it needs to talk to. Okay, so we added managed service discovery. Again, something that you don't have to build anymore. Just deploy and your services register to this service discovery feature, and then they can locate one another easily, right? Again, no plumbing. We also added CICD capabilities, so to automate deployment. So we have a number of services called code commit and code build, code deploy, code pipeline, etc. And they fully support Docker containers. So you can build fully automated CI/CD pipelines for your Docker clusters. Okay, Docker is really a first-class citizen here. You don't need to tweak. It doesn't have to be weird. It's supported out of the box. We added Windows containers because some people want to do that. Right? Why not? So yeah, no comment. Yeah, no comment. It's fine. It's fine. It's a big world. It's a big world. I'm gonna get into trouble again. You'll cut that part, right? Okay. Anyway, so now you can do Windows containers, and you can pretty much get the same features that you would get on Linux-based containers. So again, you have load balancing and monitoring, etc., etc. So there's no reason not to have those same features for Windows workloads. Okay, so that was our first service. It was quite successful, but then, like I said, customers are never happy, and that's great. They keep pushing us. They're like, okay, yeah, it's still based on EC2, right? So we still need to worry a little bit about VPCs and security groups and IAM roles and load balancing. Can you make it even simpler? What we really want to do is run tasks. Can we just take a container and run it and not worry about anything? And we said, okay. And so we built another service called Fargate. And that was launched over a year ago now. So Fargate is fully managed containers. Okay, so no clusters to create, nothing to worry about. Okay, just bring your container and run it on fully managed infrastructure. Okay, so it's really just take that thing, run it, and that's it. Okay, so that's what that's what Fargate is. So the way this works, okay. So I guess that's what ECS looks like, right? A bunch of EC2 instances with tasks. Okay, a task is at least one container. It's 1 to n containers. Okay. So that's what ECS looks like. Okay, so yeah, EC2 instance, ECS tasks, and running on that host, you have a Docker agent, you have the ECS agent talking to the ECS backend. So you have a few more things that you need to set up. And customers say, no, we don't want to deal with this stuff. Make it simpler. Okay, so, well, and that's the ECS backend I was talking about. So we went from this to this. So the EC2 part is just gone away completely. So you just take your tasks and you run them on the Fargate managed infrastructure. Okay, and that's it. So it's simpler than ever. And you can pick, the only thing I guess you have to pick is the configuration. So how much processing power, so to speak, do you want to assign to specific tasks? So you can pick fractions of a virtual CPU, and you can pick different memory increments. Okay, to have the right level of cost and performance for each task. Okay, not having to worry about which instance type should I use and blah, blah, blah. Okay, so super simple. So both are, have been available for a while now. And then somebody said, yeah, it's okay, but all right, but we kind of like Kubernetes. ECS is fine, Fargate is very good. What about Kubernetes? I said, oh, okay, all right. And we built EKS. Okay, so K is for Kubernetes, Elastic Kubernetes Service. Anybody using Kubernetes? Okay, sure. So, see, we thought about that. And well, I guess one of the reasons we did it is we found out, do you know about the CNCF? It's an industry-neutral organization that promotes cloud-native technology, and Kubernetes is one of them. And they ran this huge study, and they found out that 57%, that's a number from last year, so it may have changed a little bit, 57% of Kubernetes runs on AWS. So people so far, they were running that on EC2, right? So anybody enjoys running Kubernetes masters and fixing Kubernetes masters? See? Yeah, that's a nervous laugh. It's like, oh yeah, no. I'd rather jump off a cliff or something. Yeah, so Kubernetes is, okay, let's agree on the fact that it takes some setup, right? And especially in production, keeping that thing on its legs in production is not something that's super easy. So we said, okay, yeah, we have so many people running Kubernetes, we need to make it simpler for them. Okay, so that's pretty much what we did. We've taken that pain away of managing the Kubernetes plumbing. So you can just bring your Kubernetes pods, as you guys call them, and you can run them on, yeah, it's fancy animation here. Yeah, amazing. Yeah, you can run them, you can create your EKS workers, and they can join a cluster, and you can run your pods on them. Okay, and you don't need to worry about masters, and you don't need to worry about all the complex setup. And you can still use your standard Kubernetes tools to manage the cluster. Okay, so it's kind of, it's kind of like, it's similar to ECS. Okay, except you can use the Kubernetes templates and configuration, but it's the same idea. Just bring your pods and run them. And if you're wondering whether this is real Kubernetes or fake Kubernetes, this is actually certified Kubernetes. So it's, again, nothing weird. And then nobody asked for anything, right? I guess at this point they were like, oh, okay, all right. And then they said, haha, what about that one, right? Firecracker. And it was one of the big surprises at reInvent. So actually we open sourced it. And well, in a nutshell, so Firecracker is a lightweight hypervisor. And it's the one we use for Lambda and Fargate. Okay, so you can go and test it, you can download it, you can build it, you can run it. But this lets you create very lightweight VMs. You just start the Firecracker binary. It's a single binary, so it's very easy to deploy. And you have a REST API that lets you start VMs, configure VMs. Okay, so if you want to build your own environment for containers, or if you want to build your own environment for your own version of AWS Lambda, well, you could go and try it. So it's very lightweight. We actually have a benchmark where we create, I think we create 5,000 VMs. I'm going to say something stupid. I'm going to say 4 seconds, but I don't think that's the actual number. It's super lightweight, super lightweight. Okay, so go and look at this. It could serve a purpose in your infrastructure if you really want to build on-premise stuff, like on-premise Lambda or on-premise Docker at scale. Why not? But anyway, this is what we use, and it's open source now. So if you're curious about all those things, this is the one place to go. This is just a very high-level introduction. Some of these services, if not all, are part of the free tier as well, so you can definitely experiment. and let us know what you think, right? And then you can come back to us and say, what about this, right? What's missing now? I don't know, okay? I don't know. All right, I'm done. Now I can have a drink or 10. And thank you very much. I hope you learned a lot. And again, if you want to stay in touch, if you have feedback, questions, etc., I'm happy to connect on LinkedIn, or of course you can ping me on Twitter and yell at me. Okay. All right. Thank you very, very much.